All right, hello guys. Welcome to another one of our supplemental React sessions. And today we're going to be talking about custom hooks. Why would we want to use them and how would we use them? So far in some of our sessions, we've talked about how we can really follow a lot of really nice best practices when making React app and how we can organize code. And ways we can do this are listed as shown, with the compartmentalization of state logic, with different hooks we can use like use reducer and use context, the functional programming paradigm, higher order components, and separation of concerns. Well, this week we're going to talk about how custom hooks really embody all of these concepts and how we're going to use them. So first, let's talk about how functional hook components handle state logic and how it's different a bit than the old class-based method of writing React components. Dan Abramov, one of the founding fathers of React, said this when he was unveiling hooks to the world back in 2018. With hooks, we separate code not based on the lifecycle method name, but based on what the code is doing. And one of the reasons why this is really nice is that with React hook components, we don't need to keep track of all of our state within a giant this.state, and we don't need to have all of our use effect logic all bundled up inside of one single componented update, but we can instead track all of our variables and what happens to our variables independently and discretely of each other. And this way of tracking things discretely and independently from each other is called discrete logic. And with discrete logic, we have something called separation of concerns. And with separation of concerns, we're able to split up our code and our style of thinking in different ways. One of these is splitting components into ones that only handle state logic and into ones that only handle displaying content onto the screen. And we saw this in the past with the use context hook, where we're able to make a context provider which handles a lot of state logic, and we're able to make pure functional components that don't use state or use effect at all, and are simply in charge of showing what state variables get changed in the context in our app. And another way that we can have discrete logic is with separating each aspect of the component lifecycle into what we want to do instead of when we want to do it, which is basically the embodiment of this quote right here that Dan Abramov has said. And to take a closer look at this, let's take a look at the hooked way of writing components as opposed to the class-based. First, we're going to look at something with hooks. Within our hook component, we want to keep track of three different things in state. We want to keep track of a string, a number, and a Boolean. And we're going to want to keep track of some of the changes that happen to them. So we have a use effect to listen to the state string. We have a use effect to listen to when the state num changes. And finally, we have another use effect to listen for when the state bool has changed. And when you take a look at this code, you can see how we have organized many different use effects to handle the code. And we say that, oh, if the set state string is not associated with the set state num, then I'm going to have a different use effect to listen for either one of them. And if we compare it to the class-based component way of writing things, like so here, we can see that it's a little bit different and it's a lot more centralized. And this has like everything all in one place. As you can see here, we have our state string, our state num, and a state bool all inside of our this.state, which we have to call inside of our constructor. And whenever we want to listen for something changing, we cannot specify what is the thing that changes when we listen for, because we only have a single componented update function that we can see here. And you can see that we have to have if statements comparing the previous state to determine if it is changed from previous and console logging it here. And as you can see, this is a lot more centralized way of writing our state logic. And that begs a question. If in an earlier session, we talked about how use reducer was really nice because it allowed us to have centralized state logic, why is it better to have discrete logic for things like here, as opposed to having centralized logic like what we did inside of a class-based component? Well, one of the great reasons why the use reducer was really helpful is because it allowed us to centralize state logic that wanted to be centralized. And we can see how do we know if we want state logic to be centralized or not? And we can take a look at that through a simple digraph that I've made here. So we have here is that we have like let's say we have 5 different things inside state that you want to keep track of, numbered 1 through 5. If 1 and 3 depend on 2, but 4 and 5 only depend on each other, should we centralize these two? As we can see, there's like a clear divide between 1, 2, 3, and 4, 5. And with use reducer, we're able to pick and choose what things we want to centralize. But the problem with class-based components is that for the numbers, let's say 1, 2, 3, 4, 5 in this case, even if we don't want to centralize them because they don't depend on each other, we're forced to do that, which allows a lot less leeway and is like not as nice as centralized. And sometimes there's data that we don't want to get centralized, but we have to with class-based components. So now that we talked a bit about how functional components allow us to have discrete logic if we want things to stay discrete, we can see that with custom hooks, we have the same concept of discrete logic, and it allows us to have logic that is distinct from other parts of the application and combine them into a simple and easy to use function that we can call from anywhere. And we compartmentalize logic into its own individual function. So why use custom hooks? Well, custom hooks are useful for, as it says here, repeated compartmentalizable logic that we use multiple times throughout an application, or when we want to separate our logic across different functions. Like what we said is that a custom hook is essentially a function that we can call. And we can call it from anywhere inside of the function, anywhere inside of our React app, whenever we want to use it. And when we hear saying like, oh, we have some data that we keep track of that we want to hear and listen to anywhere inside the application, at first we think, hey, wait a second, this sounds really similar to the use cases for use context or React context. And now we're going to take a look at a small example that compares and contrasts, like using React context versus custom hooks and seeing how custom hooks sometimes can be better performance-wise and help solve some of the problems that we run into with React context or prop drilling, where we want to show which are the other ways that we can keep track of data that we want across multiple different componentries inside of an app. So to take a look at that, let's take a look at an example that we have prepared. So what we have here is, let me full screen this real quick, make this bigger. What I have set up here is a small little React app that contains a componentry, a window. And what we can see is that each new part of the component, like you see how this is green, this color is gray, and the inside is green again. Each color change represents a smaller component or a component that is further down the component tree. So what I mean by that is that this window with context is one component which contains this gray component, and this gray component contains these little green components inside of it as children components within the component tree. And we can see that we have the same example set up multiple times using custom hooks, context, and prop drilling. And now what we're going to do is that we're going to look at something that's called the React Dev Tools. And what the React Developer Tools, the Google Chrome extension, allows us to do is that it allows us to profile our React apps. So we can see how many times do things re-render, we can see how long it takes to re-render, and we can keep track of performance within our React apps. So first, let's take a look at use context. Something that is nice to remember is that with context, anything that you wrap inside of context, whenever a state value changes, you have to force to re-render everything that the context was inside of, or everything that depended on the context. So if we take a look at for the code that uses the context in this case, let me pull it up real quick. Yeah, we can see that inside of the context page, we wrap it inside of a provider function, which means that our entire page is listening for the context of listening to the window's height and the window's width. And let's see how many times everything is updating. Now, first, when we're taking a look at the page that we're looking on right now, we see that whenever we change the width or the height, the only thing that changes is the stuff inside of the middle innermost green section, as you can see here. But however, this right here, this gray component is what is being wrapped inside of our context provider, which means that if we take a look at the React developer tools, for instance, which let me pull up real quick. Developer tools. Yeah, so the way we can access the developer tools is that we go to this arrow right here. We click on the React profiler, and we see a little blue dot over here. Whenever we press this blue dot, we can basically record what's happening in our React app. We can see how many times things re-render. So let's try clicking the button and see what happens inside of our context page. Boop. And let's move the window around, move it up and down, side to side. And let's take a look at what the profiler has told us. And what we can see is that we have the window provider, which is highlighted over here. And we know that whenever a state value inside of the window provider changes, everything that is inside of it, or everything that's inside of the component tree of window provider, is forced to update. So this means that this context page content over here, the intermediate component, even though it says on the right side, it did not render during this profiling section, since it's wrapped inside of the context provider, we know that it has forced to re-render multiple times, as you can see on the right side of our screen. And this problem of having this little gray component in the middle re-render, even though it doesn't care about the height and width, we can see that that problem still persists even with prop drilling or passing down props across a component tree. So here is another approach that we can use aside from custom hooks. And with prop drilling, what happens is that we keep track of the state logic to see the window width and the window height. We keep track of it inside of this gray component, and we pass it in to the children component below it in the component tree. If you guys want to see how that works in our code, let's take a look. So we have intermediate component, which keeps track of our state variables for width and height, as well as our use effect to set up our window listener. And even though the gray component itself doesn't use it, we see that it passes it in to its children component called son and daughter as shown. And now let's take a look at the profiler. If we try changing it again, let's start recording our profiling our content to see how many times you force things to update, we can see that even though the intermediate component doesn't care about the window width and window height, but its children component do, we see that it's still forced to re-render. And why is that the case? That is because since we set up the state logic to listen for the window width and the window height inside of the gray component, even though we don't use it when we're displaying data inside of the gray component, the fact that we're keeping track of it inside of our intermediate component means that it has to re-render, which can be very costly for bigger applications. And finally, we can see how custom hooks can solve these problems of having the intermediate component re-render multiple times, even if it's not listening for these state changes. And let's see how we can do that. If we try using the React profiler again and playing with it like so again, we can see that the intermediate component does not have to re-render during our profiling session. And the reason for that is because we can see that in our children component, the way that we do it is that we simply call a custom hook that we made to listen for the changes in the window width and window height across the children component, which means that our parent component doesn't need to keep track of the window width and window height at all. And we're going to go into now how we can create this use window dimensions custom hook that can do that for us and return basically the window width and window height as an array that changes in real time. So let's take a look at how we can do that. So first, a little bit more about custom hooks. So with custom hooks, it's basically like functional composition within the functional programming paradigm. And for context again, here's the functional programming paradigm where we pass in things that we want to do across multiple functions, and sometimes functions themselves can even call other functions with functional composition. So let's take a look at an example of functional composition. What we have here is that we have a mother function and a father function. And both the mother function and the father function does their own things. And they also call a child function between the two of them. And this is an example of functional composition where functions can call other functions inside of them. And this is really useful if two different parent functions have the same logic between them, and it avoids us having to rewrite the code multiple times across different functions. And we can see that with custom hooks, we have the exact same principle. Like if we have a use with window dimensions custom hook here, we see that across the son component and the daughter component, we do not have to rewrite how to listen to the window width and window height again, because it is all contained inside of a custom hook. And with custom hooks, we know that to create a custom hook, we have logic that can be encapsulated into a separate component, and we can create a custom hook that can be called multiple times across different React components. And what do we mean when we say that we can create a custom hook when the data can be encapsulated? And the encapsulation of data is really similar to something that we brought up before of a little digraph of, let's say, these dependency relations. And if we take a look at here, let's say we have some giant function, okay? Like if we go back into our, give me a sec. If we go back to our son component, let's say it has some of its own state variables as well. Like it has a age, because it's a son component. And then let's say that our son component also has a, let's say give it a gender as well. Something like that. Oh, and it's yelling at me. Interesting. Yeah. So what I mean by dependency logic is like, let's say we have a bunch of different things that we have inside of our state variable or inside of our React component, like the son component, for instance. We have the age and the gender, but these things like the age and gender do not care about the window width or the window height, and vice versa. The window height and window width don't care about the component's age and gender. And this allows us to create the custom hook because since this window width, window height doesn't depend on anything else inside of the component, we can take it out of the component it's currently in and change it into a custom hook, which can be called multiple times. So that was a little bit about functional composition and whether or not we can know, see if we can separate logic into a custom hook. So now let's go into, okay, we talked a lot about, oh my gosh, custom hooks are amazing. I want to use them. But now, how do we actually make them? And when we're making custom hooks, it's actually really similar to making React components and using React hooks. So some of the rules for making hooks or when we're using them is that we can only call hooks from React functional components or other custom hooks, and we can only call them on the top level of our components. So this is a little bit about using our custom hooks. So when we say that we can only call them from React functional components, we take a look back, we see that we use our custom use window dimensions hook inside of a React component. If we had a non-React function like function, JS function, like so, we're not allowed to call the window dimensions hook like so, because it is not a React component, and it is also not another custom hook. We are unable to do this. This is a big, big no-no. Do not call React hooks outside of things that are other React hooks or a React component. And one more thing as well is that we can only call them on the top level of our component when we are using custom hooks. Like, let's say here, if we have a for loop inside of our sun component, like for let I equal 0, I less than 10, we cannot call our use window dimensions hook inside of a sub function because we're not allowed to use that for use state or use effect as well. We are only allowed to use custom hooks inside of the top level of our components. Yeah, so that was a little bit about using custom hooks. And now let's go into actually making them. So let's try making the use window dimensions custom hook, which we use in our app. And we know that since it's going to be shared logic, we don't need to create it inside of the component itself. We can create it in a separate file because it's going to be shared logic across multiple things. Let's see, let me comment this out real quick. And let's go into making the use window dimensions hook. And so we can export it, use window dimensions. And remember that whenever we're creating a custom hook, it is a good idea to call it starting off with the use keyword. And that is because with the use keyword, that's how we know that from a cursory glance, we can say, hey, this is a custom hook. I need to abide to the laws of custom hooks when I'm using it throughout a component. Like I can only use it in other React things, or I can only call it at the top level of the React component. So inside of a custom hook, we can do a lot of the same things that a React component or other hook can do. Like for instance, if you want to keep track of the height and the width of our browser, we can do so using useState. Like so, const window width, then set window width equals useState. And let's say, I don't know what it is for now, let's just call it 0. And then we can also do the same thing for the window height. All right. And something else we're going to do is that we're going to be like, oh, how do we actually know what the window's height and the window's width is? And to do that, we can make a little helper function to grab the inner width and the inner height of our global this window. So let's write that function real quick. And this is, and what I'm doing here is that I am using object destructuring in order to grab the inner width property of our global window. And this returns a number. Do the same thing with the height. Inner height is height. And now we can change our default value in our use state to be the value of these functions that we just made. Nice. Alrighty. So as you can see, inside of a custom hook, we're allowed to use state variables and keep track of state, just like in a React component. So now that we have the, let's see, let's try seeing how our component works now, unless I'm getting some errors. Type void, okay, let's see. And now let's look at the return type of our use window dimensions. When we make the return type of a custom hook, it can be anything that we deem would be helpful for us. And like here, for instance, let's make it something similar to use state, where with the use state, you get an array which contains a state variable and a function to change the state variable. Let's do something a bit similar to ours use case, where we want to return an array which contains the window width and the window height, like so. And let's see if the terminal still yells at us. Nice, okay. And let's take a look at how it looks like in the browser right now. We see that, oops, let me close our React profiler real quick. And we can see that we have the window's initial height and the window's initial width, but it's not dynamically changing like we want it to. And let's see how we can fix that. Well, inside of a regular React component, we know that the way that we would want to keep track of things is with a use effect or with an window event listener. And the thing is, inside of our custom hook that we just made, we can do that as well. So let's create a use effect, which is going to set up a window listener, event listener, to change the width and the height variables whenever the user changes the width and height of their window. So let's go make that real quick. A use effect. So what we're going to do is that we're going to make callback function that we call whenever the component mounts. And basically what we're going to do is that we're going to listen to whenever the window changes. So first let's have a function like resize or handle resize. And what we're going to want to do is that we're going to want to call get window width and get window height, and we're going to set our state variables to those new numbers. Set window width, get window width, and do the same thing for set window height. And whoops, this should call the function. There we go. And yeah, now we're going to want to set up a window event listener. And the way we can do that, I forgot real quick. There we go. So this is our function that updates our state variables for height and width. And now we have to see, when do we know to call our handle resize function? That's within event listener. So we're going to add an event listener that says, whenever the window gets resized, we're going to pass in the handle resize function and call it. And finally, since we know that this is an event listener, we have that when the component unmounts, we have to return and we have to unsubscribe from this change, like so. Window.remove event listener, resize, and handle resize. There we go. And now let's take a look at our code. Let's see now that you set up a use effect to handle the changing of the window and to update our window width and window height accordingly. Let's take a look and see if it does what we want. And as you can see, the window's height and the window's width changes. And like what we've shown with the React profiler in the beginning is that this gray component here does not have to update because we simply call our use window dimensions function within our component. Nice. So now that we have created our use window dimensions hook, let's take a look at how we can use it inside of our component itself. And when we call the component and when we try using it, we see that it's really easy to use. It's just like using a useState call. You can just const, and then since we know that we are going to get an array of numbers from our useWindowDimensions function, which is going to have our window width and our window height, we can call it whatever we want with array destructuring. But for the purposes of what we're doing, we can just call it the same thing, and then equals useWindowDimensions. And we can do that within both our son component and our daughter component. And let's take a look. Something that I think is really cool to note is that even though this component, like the son component and the daughter component, you can see that they don't use state and they don't use effect by themselves, but it still updates in real time. And the reason why that's the case is because the useWindowDimensions hook, this encapsulates all of the useState data and all of the useEffect data inside of it. But if I was another developer, for me, I don't really care how it works. All I care about is I want to get the window width and the window height. And this allows another level of abstraction from us so that we can say like, oh, I don't care how I got the window width or the window height. I just want to see what happens with them, like so. And we can see how this can be really useful sometimes. Like for instance, inside of my my team's learning lab, we actually use this useWindowDimensions custom hook in order to know if we should display a nav bar or not, a progress bar on the left side. Like as you can see here, if the window screen is big enough, then we showcase the progress bar. And if the screen is too small, then we don't show it, like so. So this useWindowDimensions hook can be actually useful for stuff, which is really nice. All right. So some more custom hooks use cases. And now that we know how to write custom hooks and how to use them in our React components, we can see that it's just another great tool in our arsenal that we can use to organize React code and write better, cleaner, and more efficient code as well. If you guys are curious on some other use hooks some other custom hooks that you can make or that are available online, people have made, there's this really nice website called usehooks.com. And what it is that it's a bunch of hooks that people have made, like use toggle, use Firestore query. It's like a lot of things that you would do on a normal day-to-day basis, and they create custom hooks as well and abstract the logic from you so that all you have to do is simply copy and paste this code if you want to, and then just use it like an API call. So this is a really nice thing if you want, and you can feel free to look at this and see different custom hooks that are out there. Nice. So in conclusion, from custom hooks, we know that custom hooks take advantage of all of the concepts that we've discussed so far. The compartmentalization of state logic, functional composition of avoiding having to rewrite logic, separation of concerns, because with this function here, we don't really care how we got the window width or window height. We're simply using it, and this handles that for us. And finally, we can have the centralization of logic as well, because we know that if we ever want to change our algorithm or something for how we calculate the window width or window height, we don't need to change it across every single component. We can just change it inside of wherever we define the useWindowDimensions hook. So all in all, custom hooks are really great. And this is just another thing that we can use to help write cleaner code. Thank you guys for listening, and I'll catch you all in the next one. Peace.